Okay, hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject Mechatronics, unit number 3. So last class we discussed with the temperature monitoring system using 8085 microprocessor. This class we are going to discuss about stepper motor controller with the microprocessor and traffic light control system using microprocessor. Okay, in unit number 3. Okay, stepper motor. So we know that stepper motor is a digital motor, so which is work in a step-by-step rotation. Okay, it is rotated in the particular angles. This is used in the different applications in robotics and Xerox machines like that. They are using stepper motor for particular angle rotations. Okay, so it is a brushless synchronous electrical motor that converts digital pulse into the mechanical shaft rotations. So every revolution of the stepper motor is divided into a discrete number of steps, and the motor must be send a separate pulse for each step. So the shaft of the motor rotates in the equal increments when a train of pulses is applied. To control the direction and the number of steps, appropriate pulses are applied to the stator bindings of the motor. Okay, this is the construction of stepper motor. So this is the input from the processor. Input from the processor. So processor means here we are using 8085. So 8085 there is no input output ports. So we are connecting the 8255 with the 8085 for generating the input output ports. Here we are using the port A of 8255 for giving the input to the stepper motor. Here we are using 7401 for the stepper motor drive, because stepper motor is in the 20-volt conditions. So we need to drive the, so because here we are using giving the input of 5 volt, so we need to drive the voltage. So we are using the amplifiers. Okay, the transistors we are using. So this is the stepper motor rotor. Okay, this is excited by the some windings. So windings is we can use. So you have different kind of stepper motors, reluctant motors, magnetic rotor stepper motor, like that they have. Because the soft depend on the soft, we can uh, give the different types of stepper motor. Okay, the excitation time period between the two coils define the stepper motor angles. Because if we are using full step excitation and half step excitation process, if full step excitation process means for each step it will rotate in the 90-degree. Okay, for first step we are exciting the B and D only. So second step 1 and A and D. Third step we are excite the A and C. Then fourth step we are excite the B and D. So for each step it is rotated in the 90-degree concept. But in the half step excitations, here for each step it will rotate in the 45-degree. Okay, this is the concept. Okay, if you want per rotation 45-degree means you have to use half step excitation. Okay, so this is the excitation circuit with a series reluctance that is having freewheeling diode, motor winding, and series resistance. For giving, if you are giving the input of 5 volt means it will drive some voltage to the motor bindings. Okay, this is the concession of stepper motor interfacing with the 8085. So already we told that is microprocessor 8085, input output ports 8255, then buffer, amplifier, then bindings of stepper motor. Okay. Okay, this is the step size of stepper motor 360-degree. So by NS into NR, that is NS is the number of state poles, NR is the number of pair of rotor poles. Here we have two steps only for controlling the stepper motor. First we initialize the 8255 with the port A as a output port, because stepper motor is a output port. Okay, previously we discussed temperature means we need to use input port as well as output port conditions. So there we are using two port A and port C. Here only we are using the output port. So we are using the port A as a output. So that is we are initialize the PPI 8255 with the port A as a output port. Then store the switching sequence in the memory. This is the concept. Okay, this is a flowchart for executing the stepper motor control. Okay, start. First initially start the process. First initialize 8255 the port A as output port. Then store the switching sequence in the memory location. Then set the counter. Then out the data from the memory locations to stepper motor coil. Then call for delay. Then decrement the counter. Then increment the memory location. Then so this value is 0. 0 means if 0 is okay, if 0 means it will goes to the initialize position, then start switching sequence. If no means it will go to the set count. So this is the concept. Once we are executing this program means the stepper motor will continue